Welcome to this presentation on managing linear assets with Oracle EAM. This presentation will be given by me. My name is Arun Kumar Kaliyappan. I am the senior principal product management with EBS product management team, and also Shankar will be co-presenting this session. He is the director of EBS development team. As far as the agenda for this session goes, we will take a look at the linear asset management as a feature introduction and the different value propositions that the customer will get by implementing this feature. And also we will take a look at some of the target industries and business requirements that we have addressed for them. And also we will go through some of the key solution features and use cases that are part of this feature. And also Shankar will take us through the GIS integration architecture and some additional training materials that we have on the Oracle University forums. And also we will talk about the early adopter program that we are launching for this implementation of this particular feature. Yeah, as an introduction of linear asset management feature, this is a new feature in EBS suite release 12.2.4, which has been released in the month of August. And this enables the asset maintenance for spatially located assets. And it is an integral feature of Oracle EAM that enables the GIS system integration seamlessly into the Oracle EAM ERP system. And it improves the visual management of maintenance of spatially located assets with improved map actions. We will take a look at some of the value propositions that the customer will derive out of implementing this new feature. This linear asset management feature will support tracking of linear assets and the system specific properties which are related to linear assets, like properties and elements, which can be used for maintenance reference. And also it will help organizations who are maintaining linear assets to model their linear asset network and maintain their relationships in the system. And also it is an integrated GIS, it provides an integrated GIS system and EAM system management together for geographically located assets. And it helps in work planning and execution for which with linear details capture. And also this feature provides improved costing and multi-asset work order execution features for handling dynamic field requirements in maintaining the linear assets and as well as discrete assets that we are maintaining. Yeah. As far as the target industries are concerned, this particular feature is aimed at all the industries that maintain and manage linear assets. Let it be oil and gas industry who manage the pipelines, and or it could be the utility industry which maintains a large spectrum of linear assets like transmission towers or any cabling networks that are maintained. And also it could be infrastructure assets like the roads and railways and any other the bridges and such infrastructure networks that are maintained. Linear asset network in the pipeline system. So this particular diagram, it shows some of the typical components which are located in the pipeline system for oil and gas industry. So in the oil and gas industry, we may be having the production wells that are the source of the natural resource, and the fluid is pumped collected from the natural sources like the production wells, and it is transferred to the storage tanks using the pipelines like gathering pipelines. And then from the storage locations, the fluid is taken into the processing plant using the pumping stations. And from the processing plant, the fluid is distributed to the actual commercial and residential consumer places, which are like the end users of that particular natural resource. So in those, all along the linear asset network, we are having the pipelines as the critical components that run along the network system. And it is dotted with a lot of discrete assets that are part of the linear asset network system. So altogether, we have to maintain the discrete assets and linear assets together, and we may have to capture the various properties of the linear asset network system, like the pipeline diameter and the fluid pressure which is flowing through the pipeline. So all these things forms the properties that we want to track in the system, and the different elements form the different components that are located in the system, like production wells, storage tanks, and pumping stations, and so on. Similarly, in the water utility industry, we may have a similar pipeline system, and it has its own characteristic which we want to track in the system, like the properties of the pipeline diameter again, and the flow rate and the consumption detail of the water or the sewage that is being handled by the system. And again, the distribution system, it may be having the consumer endpoints which are marked in the system, and we may have to track all of them in the system. And in the road network, we may be having the road networks which are maintained, and there could be a cluster of roads that we want to maintain, and the roads, they may be having relationship with one another. And on the road network, we may have to track the toll plaza and mile markers, which are some of the critical installations that we want to use it for reference as well as maintaining them. So some of the key business requirements that are part of this particular solution feature is to utilize the GIS system attributes for maintenance planning and work initiation. These are some of the key requirements that we have come across from the customers who are into the linear asset business. And also we should have improved asset and work order visualization on the spatial map, so that the maintenance planners and the executors, they can view the asset and work order on map on a far better visual manner, and they'll be able to trigger their maintenance action from the spatially located assets from the map itself. And also we want to enable map as a central component of linear asset maintenance for tracking, because it enables more visual based maintenance, and people will be able to visualize the assets and work orders on map, and it will be far more easier for them to trigger any maintenance action from the map itself. And the other main thing is we want to establish and maintain a two-way communication system between GIS and maintenance application, so that these two systems are integrated in a seamless manner, and always there is an information flow between these two systems seamlessly. Now we will take a look at some of the key features of the linear asset management feature. So one of the main thing is that this linear asset management feature has been built on top of the existing EAM fundamental, and it has been part of the EAM solution as in a very much integrated manner. So all the existing integration touch points of EAM are remaining intact for linear assets as well, and we are enabling another key integration with GIS systems such as Oracle Spatial and Esri. So with this integration enabled, there is a UI integration between the EAM system and the GIS system, and as well as there is a API based integration also for information flow between the EAM system and GIS system. And the GIS system is going to be the master for the GIS data storage, and whatever the relevant attributes that are applicable for EAM system, they will be replicated in the EAM system. So some of the key enhancements that have been done to address this particular feature is around the asset definition area. On the asset definition, we have enhanced the EAM asset data model to support linear asset definition and setup. So that is one of the key enhancements that we have done in enabling this particular feature. And to attain that, we have introduced a lot of setup entities which are helpful for modeling the linear asset network and their information. And also the linear asset workbench is one central component that will allow us to model the linear asset network to maintain them. And on the work execution front, we are capturing the linear details during the work order execution, and to support that, we have enhanced the work order screens to capture the linear details and to maintain them and to complete the work orders. And also on the multiple asset work orders, we have enhanced the UI and as well as the functionality enhancements that have been supported to support the multi-asset work order feature. On the GIS integration enhancements, we are going to have improved visualization on the map, both for assets and as well as for the work orders. And there is going to be a data interaction improvement between the GIS systems like Oracle Spatial, Esri, or any custom GIS application and with the EAM system. And also we will be supporting new map actions such as dynamic segmentation of assets and locating the linear data on the asset along with the linear assets, and also locating the base map data and locating the GIS area on the map. So these are the different map related new actions that are going to be supported as part of this feature. Okay. So now we will take a look at some of the key enhancements that have been done in the core EAM product on the asset route functionality. So this asset route related enhancement have been done to support the multiple asset work order feature. So, and we have introduced the flexibility in the asset route management for cost distribution and quality results capture. And also we have enabled the asset route to be modified at the work order level. So we will be having the work order route as a new feature that is coming up for work order execution, where planners can modify the work order asset route on the fly at the work order level. Here we are looking at the screenshot of the asset route enhancements, and this is a new page for the manage asset route, for managing the asset route. So using this manage asset route user interface, we'll be able to define the various setup controls that allow the flexibility for the asset route management at the work order level. So we are having the new feature to have the sequencing of the asset route member assets. So by specifying the sequence numbers in the asset route management, we'll be able to identify what is the priority of the asset when we want to take up a work order on asset route. And also we'll be having the cost distribution percentage specified at the for the asset routes member assets. And this cost distribution percentage, it need not be equally distributed percentage like it existed before. And we can have the differential cost distribution percentage entered for each of the member assets, and as long as it sums up to the 100%, it will be the system will allow us to specify any variable cost distribution percentage for member assets. When we are executing the work order on the asset route, we are going to open up a lot of flexibility to modify the asset route at the work order level. So we will be having the option to add an asset to the existing asset route, or pick an asset from the existing asset route and to delete it for that particular work order context alone. So this way the planner is at the full flexibility if he wants to modify the asset route at the work order level. So we need not be constrained by the predefined asset route setup, and based on the dynamic needs of the field, they can completely create a new work order route and they can plan the work order for that particular asset route. Some of the costing enhancements that we have done for linear assets and which is applicable for most of the discrete assets as well. We will be having the ability to update the asset number on released and transacted work order. So with this feature, we will be able to update the asset number on a work order which has been released and transacted, and it is having some actual cost also. So with this enhancement, also we are trying to address the asset route cost distribution process, which was constrained by the equal cost distribution earlier, and we are having the flexibility of having the differential cost percentage for the member assets when the asset route cost allocation happens. And also we have improved the asset cost drill down by including the asset route work order details in the work order drill down details, and now the asset drill down is going to show the asset route work order as well with the apportioned percentage value that comes from that particular work order and which is applicable to the member assets that we are querying for. And also we will be having the ability to view the asset cost roll-up value based on the user defined relationship that a planner can create and attach it to any network of assets. So this screenshot shows how do we define the relationship and how we can view that particular relationship in the asset cost drill down. And currently we support only the parent-child relationship for parent-child relationship based asset cost roll-up, but currently using this new feature, we will be able to view even the relationship based costing roll-up. We will take a look at some of the use cases which are supported as part of this linear asset management feature. And to address some of the map visualization use cases, we have the assets on map feature enhanced, and now we will be able to locate the assets by asset details based on the EBS data. It could be the asset number details, and we can go to the map without having any context asset in the context asset carried over from the EBS page, and we can simply go to the map and we can query for the asset on the map. And also we will be able to locate the asset by drawing a particular GIS area on the map. It could be a circle or it could be a polygon. And also we will be able to locate all the linear data on the assets on the map, like properties and elements and relationship. They can be visualized on the map. So here we are looking at some of the use cases and how they are shown on the map visualization tool. So here we are looking at the search feature on the map, where we are able to query for the asset using the EAM asset number. And also here we see that we are able to specify a radius for a circle to be drawn on the map, and then on that map area that is drawn, we are able to fetch all the assets that are passing through that particular radius. and we will be able to query all the linear entities like the properties, element and relationship, and using the drop down we can select any entity that we want to visualize on the map, and we will be able to query them, and they will be highlighted on the map. Similarly, we will be having the map visualization enhancements available for the work orders on map as well, and on the when we are addressing the work execution related actions on the map, there are some of the key enhancements that have been done are the dynamic segmentation of asset on map, and also we will be able to create the work order on based on the linear attributes or reference points or base map properties, and also we will be able to track the work orders which are located in a particular organization from the map viewer tool. So, we will be able to specify some of the start and end points, and we will be able to capture those start and end points on the map tool itself, and dynamically we can create a segment on that particular start and end point, and then we will be able to create a work order for only those particular dynamic segments that we have created. And also we will be able to query the linear properties on the map, and only for that particular property that is occurring we create a dynamic segment, and for those captured properties we will be able to create the work order. And also we will be able to search for the some of the base map properties like address string, and then we will be able to quickly point out to that particular location, and we will be able to narrow down to the assets that are located in that area. Yeah. So, with that I hand it over to Shankar to talk about the GIS integration architecture of this linear asset management feature.
I am Shankar. I am going to take over the GIS integration architecture of linear assets. With linear assets, the GIS integration is kind of very important, because when the data is in a linear position, the work segment, as you saw some of the amazing features which has been introduced by Arun Kumar on creating a lot of work segments on the linear assets, you need a proper GIS integration architecture for linear assets. Before you understand the integration architecture, let's understand what is a linear geometry. When you take a discrete asset, it's very simple. You have a latitude, longitude, you have to just introduce a latitude, longitude for a discrete asset, and you can plot it on a map. But when you come to a linear asset, you need a series of latitude, longitude to really visualize that on a map, because it's a kind of a continuous geometry which needs to be defined. It's like a polyline which you need to see on the map. So, you need a kind of a special GIS capabilities to kind of store the data in the system, GIS system, so that we can visualize that on the map. So, what you see here is for a linear geometry, there is a series of coordinates like x1, y1, x2, y2, and xn, yn, which actually when you try to kind of connect these points, you actually get a polyline. With a linear reference, you also have a third dimension called measure, whereas you see m1, m2, m3, mn there, which actually points that particular location is at which measure. So, a linear geometry will have a start point and an end point of a geometry, which actually says it's a start measure and an end measure. It can also have measures at intermediate points too, but that's kind of optional. So, what I explained theoretically in the previous slide, this you see in a graphical way, the blue line which is there, which is nothing but a series of x1, y1s which has been connected, and which is a polyline, and which also has a measure value on each and every latitude and longitude. So, once you have the geometry in place, you need to associate that geometry to a linear asset at EAM. So, we have in linear asset, we have linear segments. Once you connect the linear segments with the geometry, you should be able to visualize that in the map. So, it's all about getting the geometry from the GIS system and try to link it to the EAM linear asset, and then you are there ready to visualize that on the map. We support various map integration. There's an existing profile which is already there, CSI Map Viewer, that has been enhanced to have additional options to kind of support various map integration. We support pure ESRI integration, This does not need Oracle Spatial. If the customer already has a ESRI in place, we can just connect to the ESRI GIS system and visualize the data or visualize the linear asset data on the map. The second option is the Oracle Spatial, where you use the EBS system itself as a GIS platform. You can store the geometry. I'm going to talk about it in a couple of slides down. You can store the geometry in the EBS system itself, and you can actually visualize that on the map. The third option, custom GIS. If customers are not in ESRI and they don't wish to have the EBS to maintain the geometry, they can use, and they already have a other GIS system in place, they could actually integrate with the EAM solution and still visualize that on the map. With all this integration, all the use cases which was talked a few slides before by Arun Kumar, that's all possible. Once we get the geometry on the map, everything is same. All the use cases, from visualizing it, searching based on polygon, visualizing the attributes, visualizing the work order, creating work segments, all that is kind of possible for all kinds of this integration. The use cases doesn't change with any of this integration approach. So now you know what's the geometry. So based on the profile or based on the integration which you are choosing, the geometry gets sourced from that system. So if you go for the pure ESRI, it's like the geometry gets sourced from the ESRI system. If it's Oracle Spatial, it's from the EBS EAM system. If custom GIS, the geometry gets sourced from the custom GIS system. Now let me spend some time on the EAM ESRI integration architecture. What's there where, right? So we have linear assets defined in the EAM system here. We have these segments, properties, elements, and relationship. The ESRI system would already have a geometry route. The route in ESRI terminology is nothing but a polyline, which kind of shows a linear geometry, a pipe or a road, which is stored in the ESRI GIS system. It's in typical the same representation with x1, y1, x2, y2 with measures also. And this ESRI route, whatever you see is a similar kind of a blue line, whatever you see in the blue color, that's a similar kind of a polyline. Now how do we get this data into the EAM system? ESRI does support exposing these routes as REST services. So they have an option in the desktop tool where they can just right click on the route and then just say publish it. The routes gets exposed in ESRI server. But for the advanced capabilities of linear referencing, you need an roads and highways plugin in both in the desktop and in the server to really connect and get it. So once you expose the routes on the ESRI system, we have a map manager. In the map manager setup, we have a provisions to provide all the URLs through which we can talk to the ESRI system. So once this is done, you're all ready to connect the geometry to the linear asset. So we have a linear asset workbench where the one which you see in the red box, there is a unique ID. This unique ID is a unique ID of a route which is there in the ESRI system. So once you try to provide that unique ID, this linear asset which is defined in the EAM system is actually linked to the geometry which is there in the ESRI system. So in the map workbench, when we have to visualize this linear asset, what technically happens is, using this unique ID, using the REST APIs, the REST API URLs which you have seeded in the map manager, we pass on this route ID to that REST API and talk to the ESRI system. The ESRI gives us back the geometry which we can visualize that and show it on the map. And you can continue your EAM maintenance actions on top of that visually seen linear asset. Next, the Oracle Spatial integration. Again, so you have the linear asset definition obviously in EAM system. The GIS also stays in EAM system. we have something called Oracle spatial route, through which can store the polyline geometry. So there is no other additional GIS system required, though the Oracle EBS database has to be enabled with Oracle spatial. The normal enterprise DB system do come with a part of Oracle spatial called Oracle locator, but that is not sufficient to do the integration, because this is kind of a little more complicated, or it is kind of needs an advanced Oracle spatial capabilities like linear referencing and things like that. You need a full suite of Oracle spatial. You have to get the license of Oracle spatial and enable it for your Oracle database, the EBS Oracle database, so that you can use this feature. Spatial route is a cool geometry web-based tool through which you can manage your geometry. What you see here on the screen is a map visualization where you can actually drag and drop, or you can just keep drawing the points. Just on a Google Maps, you just draw a line. It's as simple as it. You just have to start drawing your geometry using this tool. So once you save the geometry, it is nothing but saving the polyline into your system. The polyline, as I talked, it is just an x1, y1, x2, y2 kind of coordinates which get stored in the Oracle spatial system. We again have a kind of a map manager, just like we saw for Esri. Of course, we would not be it's a little slightly different because we don't capture the URLs and things like that. But one of the interesting points is the map layer. So the map layer is a way through which you can, the base layer which you see, you can either choose it as Google Maps, or it can be a Oracle Maps, or it can be a data source which comes from an Oracle system. So if you already have an Oracle spatial system in place, and if you have some map data in that system, you could possibly connect it through the data source and give the theme name, and that comes as a layer at the background on whatever linear asset you're operating. All right, so you have the geometry already there placed. You draw the geometry, and all you need to do is link this geometry to the linear asset. So similarly, what we saw for linear asset ESRI integration, the same linear asset workbench, if it's spatial route, you have a different column being shown called spatial route, where you can actually, it's an LOV column, you can click on it, choose the spatial route, and you're all set to go. The geometry is linked to the linear asset. The custom GIS architecture. So this is the third option where you wanted to integrate with the custom GIS like eSpatial, OpenSpatial, or any other any other GIS system. So we have opened up a custom API hook. So the implementers or partners, if they can implement that API hook, somehow connect to the GIS system, the custom GIS system, and return back with a SDO geometry, we can visualize that on the map. For this integration, again the EBS system, the EBS database has to be enabled Oracle spatial. Though you have the custom GIS, still after we get the geometry, to do the other operations on this geometry, we need the spatial enabled on the EBS system. So this integration also needs the Oracle spatial license on your EBS. Again, the linear asset workbench, there you can have the unique ID typed in. So when the custom hook gets called for that particular linear asset, this unique ID would be passed to that custom hook, and you could use this unique ID, talk to the custom GIS system, get the geometry back, and we can visualize that on the map. This is an interesting slide, right, where how do I map the GIS geometry with the asset? We have various options. One of the important design consideration which we took is your geometry should not be defining your assets. The shape of the geometry or these pieces of the geometry should not be defining the number of assets which you will be maintaining. The assets from EAM is more of administrative purpose, the way in which you have to do the costing, the way in which you have to maintain it. So you have to group the geometry or use a part of the geometry to actually define the asset. So you could map multiple ways. You can actually map one asset to one route. What I mean is one geometry can be mapped, one complete geometry can be mapped to one asset, and then it can be maintained. One asset can be mapped to multiple geometries. So let's say you have multiple geometry splits in ESRA system, but you still wanted all of them to one single asset, you can do that. Or you can map many assets to one route. Let's say the geometry is quite big and it kind of spans across multiple states or multiple cities. So you just wanted to have multiple assets to be maintained. A part of the first part of the asset you wanted to maintain as, for first part of the geometry you wanted to maintain as one asset. The second part of the geometry you wanted to maintain as another asset. You could possibly do. So you have a many to many options. We have linear segments in the linear asset management through which you can do the mapping option. The other thing which we have come, whatever use cases which we have shown in the map workbench, I'm sure that there will be many other business cases which needs to be addressed, like getting some data and visualizing on the map, like customers' data, getting service requests, or visualizing the costing, or whatever it is. So we have come up with a kind of a user-defined toolbar support through which you can actually satisfy these requirements. It's a small setup screen through which you can actually feed in your name of the button or the whatever action, and there is an API text box through which you can feed in the custom API call. And whatever actions you have added in the toolbar, it comes as a drop down in the workbench, map workbench. So when you choose that option and click on go, it actually calls your API, the custom API. And if the custom API returns the data in a specific format in which we requested for, we could visualize on that map. So this kind of opens up many use cases which you can define or you can design for your business cases with a simple custom extension, and still use the same map workbench, but visualize or do actions or visualize more than what we kind of provide. So overall, the linear asset management, we have a different, just to summarize, we have a different integration option based on customer existing preferred spatial solution. We are not only ESRA, we can do ESRA, spatial, custom GIS. We have various setups, properties, elements, and all those things, so that which are practiced and varied in each business functions. You can fully leverage the EAM features. So the linear asset management is designed on top of the EAM. So whatever features the EAM has, it's all supported, and it goes with integration with easily. These are some additional resources, the MetaLink notes, where you can know more about this feature. So this is one of the ways through which you can connect to the development directly. We have earlier adapter programs. So if you as a partner or implementer, or you as a customer wanted to work closely with the development, you could reach out to us. We can collaborate with you and work with you to kind of do a successful implementation. This is just definitely not a replacement for support, but you can possibly use us to get a direct feedback, because we know the features which has been introduced in the product. We could kind of give more details on it, and you can have a successful implementation in your premise. That concludes the presentation. Thank you for watching.